Okay, so let's continue our lesson on central angles. So here we have an algebraic setup. In this case, what we have to do is realize that the arc length here is 26 degrees, the arc measure, I should say. So the angle here would be 26, the angle here would be 26, and the arc here would be 26, right? Next, we can realize that this forms a half circle, right? So if we add these two expressions, we should get 180 degrees. So if I have 15x minus 26 and I add that with 26, that should equal 180. These cancel. So I have 15x equals 180, and then divide by 15 on both sides. Okay, so let me get my calculator for laziness purposes. So 180 divided by 15 is equal to 12. So we get x equals 12. Okay, for this one, here we have a situation where these are opposite from each other. So in this case, these are equal. Okay, so we set them equal and we solve for x. Subtracting 8x, adding 22, and dividing by 2. So we get x equals 17. And for this one, what we can do here is we can notice that if we combine these two angles together, that would equal this angle, right? Therefore, if we combined these two arcs together, it should equal the same as this arc. Okay, so what we would do is add these together. So we'd get 15 plus 18x minus 2, and set that equal to 103. So here we can add or combine these numbers. So we have 18x plus 13 is equal 103. And then we subtract 13 on both sides. So we get 18x equals, if you do the math here, it looks like 90. And then we divide by 18. Okay, so if you're having trouble with your mental math, you can divide on here and get 5. Okay. Oh, incidentally, this one also wanted to know these values. So let's plug 17 back in. So if we plug 17 back in for x, for example here, we would get 17 times 10, or 170, subtract 22. So that should be 148, right? So these arcs are both 148. And then the neighboring arc would together have to form 180 degrees, since it is located on a diameter, right? So 180 degrees, subtract with the 148 we already have, that gives you 32 degrees for these smaller arcs. And also the smaller angles would be 32, right? 148 for these guys. So let's see what they want. Arc AD, that's easy, it's just 148. Arc CD, that's 32. Arc BDC. So if you notice, B to D to C is this way. So we go a full 180 plus an extra 32. So a full 180 plus an extra 32, that's going to be, is it 212? I think so. 212. Okay. So now you guys can try numbers 8 and 9, and I'll pause here for a moment to allow you to try them. So just hit pause on the video. Okay, so now you've had a chance to try these, and let me just go through them quickly. So here, this and this, if you add them together, you should get 180 degrees, right? Because this is a diameter. So if we add these expressions together, here we'll get 22x, okay? And then we have negative 41 with 23. So if I just subtract these values, that would give me, I think, 18 negative. And so when you combine those, it has to then equal to 180 degrees. So if we add 18, we get 198, right? So 22x is equal to 198, and then divide by 22. So let's see, if we divide this by 11, that's equal to 18, and then divide by 2 is equal to 9. So x equals 9. Then we plug this back in, say over here. So 9 times 5 is 45, plus 23, that's equal to 68. Okay, so arc JK would be 68 degrees. So would this angle in here, so would this angle, and so would this arc. And then we would find the complement, or excuse me, the supplement of 68. That's 112. That would go here. It would go here. It would go here, and also here. So arc MJ is 112. Arc LMK, starting with L, going to M, going around to K. So notice it's 180 plus an additional 68. So that's going to be 248 degrees. Okay. And for number 9, it's more of the same, but here I'll just post up the answer, which is this here. Okay. All right, so on to the next part. So this is quite important, arc length. So the formula that we're going to be using is the following. Maybe I can start with a quick example. So let's say I have a circle, and let's say I know that the radius is 5. Okay, and let's say I know that I'm going halfway around the circle, right? And in particular, I'm going to say this is 5 feet. So we know the idea of circumference, which is 2 pi radius, right? So if I wanted to find the circumference of this, I would do 2 pi times 5. So that equals 10 pi, okay? And for this chapter, we're going to be typically leaving things in terms of pi. So we don't have to type the pi into the calculator, all right? So that's the circumference of the entire circle, but here I'm only traveling around halfway around the circle. So then I would have to divide this by 2, and that would allow me to just write 5 pi as my result, right? So that would be the arc length, okay, if I was to go halfway around this circle. And this is actually measured in feet. So if you wanted to get the actual distance in feet, you could actually put 5 pi in the calculator. So 5 times pi, that would give you 15.7, okay? So it's about 15.7 feet to go halfway around the circle. But how do I know if it's halfway? Well, basically it's 180 degrees out of 360, right? So in general, let's say I wanted to go maybe only 30 degrees around the circle. So let's do an example like that. So if I went only 30 degrees around the circle, okay, and again, my radius was equal to 5, how would I then calculate how far I've gone? Well, it's 30 degrees out of 360, right? So if you reduce this in your calculator, let's see how to do that. 30 out of 360. Math, enter, enter. And you get 1 out of 12. So this means you went 1/12 of the way around the circle. Okay? So if you went 1/12 of the way around the circle, and the total circumference, which was 2 pi r, which we found to be 10 pi, right? Then I can just apply this fraction to my circumference, okay? So I could take that circumference and I could times it by 1/12, and then I'll have my answer for the actual arc length, okay? So that's the arc length. And this could reduce, of course, to 5 pi over 6, okay? So, time for a formula. So if we have our situation of going x degrees around a circle, whole circle has 360 degrees, and then I times this by the circumference, that will give me the arc length, okay? So L equals x over 360 times circumference. So let's put that formula here. X over 360 times circumference, okay? And let's try an example. Right, so here we know that EB is 15, so that's the radius, r equals 15. And find the arc length CD. Notice they're asking for the length, not the measure. If it asks for the measure of arc CD, that would be very easy. We would say it's 68 degrees, right? Sorry, not 68 degrees. Because this one is 68, so this would be 180 minus 68, right? So that would be, is it 112? Yeah. So this for CD would be 112. But that's not the arc length. That's the arc measure. Okay? This is the measure of arc CD, which is not what they're asking for. Notice there's no little m there, and they do use the word length. So to get the arc length, what do we have to do? Well, we have to do more work than just this. So what's our next step? Our next step would be to bring out the arc length formula. So the arc length formula is the number of degrees that we're going. So in this case, it's 112 out of 360, and we times that by the circumference. In other words, 2 pi r. And we know that r, in this case, is 15. Okay? So 2 times 15 is 30. So we can write 112 over 360 times 30 pi. And then if you want to put this into the calculator, let's see. So we do 112 divide by 360, okay, times that by 30, okay, and then you could times by pi here, or you could turn this into a fraction as well. So you get 28 over 3. So if you want to put it as a fraction, 28 pi over 3, okay? So if you look at the instructions, it says round to the nearest hundredth. So that means that they actually want you to multiply through by the pi. So we can do also times pi here, and 29.3215. 29.3215. Whoops. And if you want to round to the nearest hundredth, so this is the hundredth place, so that means you would use this to see if you want to round up or down. And in this case, we want to just leave it as it is. Okay, so you just chop those off, and that would be the nearest hundredth. Okay, so let's try one more of these. So we have VS equals 12. All right, so that's going all the way across here. Find the length of arc UT. So arc UT is this one. And first of all, we should figure out how many degrees it has. So we have got 127 here, we've got 90 here, right? And if you notice, these are equal, are they? Yeah, I believe they are, because here we have an X, and we have angles across from each other in an X, so they must be equal. So here, if we do 127 subtract 90, that gives you 37 degrees, and that can go on the side over here. You see, because 37 and 90 would equal 127. So now this also would be 37 degrees, but they're not asking for the degrees of the arc, they're asking for the length. So we do 37 over 360 times the circumference, 2 pi r. That's the arc length formula. So we can put this whole thing in the calculator. So you do 37 divided by 360 equals times 2 pi times 12. You get 7.749. And the 9 means to round up, right? So 7.75 would be a good nearest hundredth. All right, so now you guys can try some on your own.